Okay, so exam. Let's talk about the exam. So there's like 15 to 20 people that have not taken it yet. So if you have taken it, you're not talking about it with anybody. So not until tomorrow should you discuss it with anybody. And if you haven't taken it, you're not talking to somebody who has about it. And then I'll submit this all the forms tomorrow morning. I'll get the results tomorrow afternoon, and I'll try to crunch the numbers by Saturday. So just look on Blackboard. You can see your score, and you can see how you get your score out of 100. Okay, that should all be done by Saturday, and then we'll go over some of it on Tuesday. All right. So no talking about it till tomorrow, and look for results late Friday, Saturday, something like that. All right, and then you have an assignment due at midnight tonight. Sometime this morning, the guys will send out the email that you're going to reply to. Let's just talk about that. So I just want to reiterate the point that everything we do, we're going to use in the future. So. And that includes graphing calculator. So about a week ago, we did a project with attendance and temperature. You filled out the papers and you built this graphing calculator file that showed the function and then showed an animated an image that showed the change in temperature and the resulting change in expected attendance. And so in doing this, you can't really forget what you did there. You can't kind of start. It's like you put graphing calculator on the shelf, and now we're starting over again. The things that you learned in that project are essential. They needed to be learned. All right. So when I write k equals 0.5 in the first line, what did I do? Is that going to graph something? No. It just assigns a number to this variable k. And then similar in the second line, I'm assigning 3 to a and 1 to b. Okay, in the next line, we want to set up a slider that's going to represent the value of delta x. Okay? If I use the variable delta x, so remember to make us a string of characters into a single variable, you're going to do backslash. Okay? And then on a Mac, the delta is option J, and then x. And now if I do backslash again, now that set of symbols is a single variable. Graphing calculator has no idea that we want that to mean delta x. I could just as easily have done tree. Okay? This is just as good. Graphing calculator has no idea. You're just defining a variable. So on a PC, you can't get the delta symbol. There's no shortcut for delta. So you might do something like this, del x. Graphing calculator, there's nothing built in graphing calculator that when you do the symbols del x, delta x, it automatically knows. It's just you're just creating a variable. So we know what it is. We know that we're going to make that be the amount of change in x. But it's just a variable. Tree, hat, whatever. Fido. Okay. So we want that to be a slider, 0 to 3. I think 0 to 3, 0 to 5, whatever. Okay. So when you do the slider, it's the lowest value on the slider to the highest value, and if you don't put anything else, it'll just by default will do some number of, I don't know, numbers in between. But if you want to specify how many steps, then you do a third value. So say I want exactly 200 steps. Or I want exactly 50 steps. That's good. 50 steps will mean, what, every 10th.
You just type in slider and pop it up.
If you type in slider, it should come up. Yep. So now by doing 50 steps, 0 to 5, each step is a tenth. Okay? And then, so then you can do del y. All right? And so y, so I've defined this variable del y, backslash del y backslash. And so what does that, what's the equals 1 about? Well, we just defined a variable, and by default, any parameter or variable that you define by default, it will give it the value 1 to start with. Okay? So does the del x line graph anything? No. Does the del y line graph anything? No. So why aren't I getting this image that you see on the assignment sheets? Where is it? Right? So you're supposed to put these 4 lines in and then get this graph, right? No, none of these produce a graph. So that was the whole point of that attendance and temperature project, that you learn the ins and outs of graphing calculator. All we're doing is assigning values to variables here. We haven't told it to graph at all. So your job is then to, in the remaining, so adding more command lines to create the situation, the graphs that are given. You're going to graph the line with a rate of change of 0.5 and a given 0.31, which can be changed, right? So after we get all the graphing, we can go in and change that and get something new. And then you want to graph the change in x, the amount of change being whatever we choose on this slider. And then the starting value of our change in x is going to be their n slider, right? So the n slider was the built-in slider that pops up below whenever you hit n. So the value of the n slider is going to be where that change in x starts, the initial value of x. And then delta x is going to be able to control how much of a change it is. Okay? And then you're going to show the corresponding change in y. And then as you select your delta x, that delta y will automatically show up, the value of it will automatically show up here. So in addition to setting up the lines that are going to graph the elements, you also have to have a line that defines delta y. So I haven't defined it, I'm just showing its value here in that green line. This is just showing the value of delta y. So in another command line, I'm going to have to define what I want delta y to be. So then as it changes, on that line up there, it'll show up as its current value. Okay, any other questions about this assignment? So you have to write the rest, which is hidden behind the graphs on that homework sheet, right? There are more command lines down here that you have to write to then create the graph according to the instructions. How did I do? Did I cover all the bases there? Okay. And then, so yeah, so if you want to use the nice slick symbol delta x on a Mac, you can do it. It's Option J, but this works just as good. So does shampoo. So does C. You know, it's just you're just defining a variable. It has no idea what delta x is. Graphing calculator doesn't know. You're just defining a variable, but we describe it so that we know what it is, right? So we choose it so that we know exactly what that variable represents to us. Okay, questions on the assignment? So they'll send the email out, and you got till midnight tonight to finish that up if you haven't yet. Okay.
Midnight tonight.
Okay, so we were doing this.
Jacuzzi problem.
And we had our input variable was what? What did our x represent? Do you remember? Number of gallons.
Y was the height in inches.
Total number of gallons in the jacuzzi. And y was
Height in inches.
height from the bottom in inches. That's a comma. Just get rid of it. Okay, and so we said that, is it constant rate of change? Do we have constant rate of change? Yes, we have two. That's right, we have two, right? So this is the idea of a piecewise linear function. We have a certain constant, we have constant rate of change, but we have a different constant rate of change on different intervals. So since we do have constant rate of change, we can use our point slope form of a line. Can any graph be represented by this form? M times x minus a plus b? Can any graph be represented by that form? What condition do we need to have in order for a graph to be written in that form? Yeah, so this is specifically a linear graph or constant rate of change. All right, so that's going to be one line, or one line will be that one, and then we'll have a second one, so we'll call that, let's say, y1, and then we'll have a second one, y2, which will be another equation that represents constant rate of change. So let me show you how with just three values, if I just know the two constant rates, and I know how many gallons is this breakpoint when we reach the step, we can write the whole function without doing any computation. Okay, watch this. So where's that point right here? So right here, we know that's, I think we found out last time that was how many gallons? 128?
Indeed, 128.
128 gallons. Okay, and this constant rate was the first one, 0.125
Boom.
inches per gallon. And this second one was 0.045.
Inches.
Now, without any computation, no calculator, no mental math, we can write the whole function now. And this is the beauty of this form that we've developed. And the great advantage that this form has over mx plus b is that now we can write this out. Okay, so let's do it. Remember on graphing calculator, if you want to do a piecewise function, so I've done j control 9x. Piecewise function will be control A. Every time you hit control A, it will. This game keeps stopping. So every time you hit control A, it'll add another line. So as many lines, many pieces as you have. So this first piece, okay, it's going to be of this form right here. It's going to be of this form. And so we've got everything we need. What's m? That's our 0.125 times x minus, so now we need a point AB. Use the easiest one we know. 0, 0. So 0 plus 0 if less than or equal to x, less than or equal to 128. We've got the 0.00 and the constant rate of change 0.125. We've done all the hard, heavy lifting to build that form, so we can just use it. Now we can just use it. That's fair. Okay? So now, second part. Here we go. No math required. All we need to know is what's the constant rate? 0.045 times, okay, x minus. So now we need a point. So we're going to start at the ending point of the previous line. This is the best way to do it. So we know the x value is 128. Okay, now this is where it gets cool. So what is the height
16
in inches at 128?
16 inches.
Oh, that's what you got last time. So I want to know if you didn't know that. What is the height in inches when there's 128 gallons in the pool? What is it? Someone got it. J of 128. Do you see this? We can use the function. We can use the previous line that we defined. If you put 128 into J in that previous line, that will represent the height in inches at 128 gallons. J, control 9, 128. Do you see that that's the y coordinate corresponding to the x coordinate of 128? So this is why this point slope form is so powerful for building piecewise functions, because we just get to the end of one piece, we can get that. All we need is the x value of the point at the end of the previous piece, and we can write the ordered pair for the next piece. This will be 128, comma J 128, A, comma B. Right? This A, B is any point on our line, so we use the first point, which is the last point on this one. Using function notation, we know the x value is 128, its y value is J of 128. Okay, if 128 less than or equal, or less than, okay. Yeah, so what would be the problem with less than or equal to?
It would be a function.
There would be a big problem with that. I think it was a 550
Yes.
max.
So it's not equal.
It's still gotta be fixed.
It's less than.
It's just less than.
So what would happen if we had less than or equal to? So what does that rule say to do? It says to do all this, and then to evaluate J of 128. And then where's it going to go to evaluate J of 128?
And define 0. 0's
Okay. Well, if this is equal, if we say equal here, then in order to look for J of 128, it's going to have to go to this line to figure out what J of 128 is. But it's trying to know what J of 128 is to define that line. So what happens? You get this infinite loop. This infinite loop. We're using this to define it, but it would need this line. If you had x equals to J128, it would need that in order to define it. So it gets stuck. It can't do it. Does that make sense?
Yes, it does.
How is it going to find J128? Well, it's going to come to the J function, and it's going to plug 128 in. It's going to say, "Oh, that means I go to this line." But this is the line. This is the line it was trying to finish when it did that. See? So it's trying to finish this line. It gets to J128. So then it's going to look for function J. It's going to take 128 and plug it in there, and then it's going to pop right back into this line. It wasn't finished yet. You see? Okay. So that's why we need strictly less than, because if we do strictly less than, now what's it going to do to try to do this line? It's going to go through here, and it's going to plug. It's going to say, "Oh, you want J of 128 here," so it's going to go, "Okay, I'm going to call on the J function, 128," and then where's it going to go? See, this 128 is defined by the top line. X is less than or equal to 128. It can get that, right? So we can get J of 128 from here and plug it in there and evaluate something for x greater than 128. So this works. This works. Okay, so using this technique, this is a recursive technique. Recursive. The function uses itself to define itself. When we're executing this line, it's going to call on the function to finish this line, and to do that, it needs to go to this line. So let's just do an example. What would J of 200 be? J of 200. What's it going to do? J of 200. It's going to say, so which line is it going to look at? First line or second line? It's going to go to the second line. And what's it going to do? It's going to do 0.045 times 200. Let's do 228. Let's make it easy on ourselves. All right, so say J of 228. It's going to go 0.045 times 228 minus 128 plus J of 128. So this is 100 times this is 4.5 plus. Okay, how's it going to find j of 21? What is j of 128? Well, calling on the j function, and now x is 128. Where's it going to go? It's going to go to the top line, because when x is 128, that's part of the domain of the top function, the first piece. So it's going to go 0.125 times 128 minus 0 plus 0. And I think in the end we'll get, is that 20.5?
Yes.
Inches. So do you see how it works? Recursive means in order to evaluate a value of the function, it's going to use that function. So it will go up the lines as much as it needs to go to evaluate a value of the function. So in executing the second line, when it gets to here, this says execute the first line. All right. Any questions on that? Does it make sense? So this is really powerful because we don't have to, we can, just as long as we know the constant rates and we know the x values of our transition points, we can just write it down. We can just write down a piecewise function without doing any math, any calculations. Okay, so now what I want you to do is let's look at that second line and let's relate this second line back to the jacuzzi situation. So when you look at so in recursive, so we're going to have ones that are 2, 3, 4, 5, 6 pieces. So we got to really make sure we know what every piece means and each part of every piece. So, sure.
If you wanted to add multiple lines, you hit Control A or J to link the same.
Every time you hit Control A, it adds another line. That's right. Is it Control Shift A in PC? Or just Control Shift A in PC? Okay, so here's some work for you. I'm going to write out some expressions in that second line, and you're going to state the meaning in the context of the jacuzzi, So, x minus 128. That gives a value. That gives a value. What is the meaning of that value in the context of the jacuzzi? Okay, and then 0.045 times x minus 128. Okay, that has a meaning in the context. That gives a value. What is the meaning of the value you get from that whole expression in the context of the jacuzzi? All right, and then j of 128. What does it mean? And then the whole thing. So I'm going to give you about 5 or 7 minutes. This is crucial that you can look at the parts and say, oh, this means this about the jacuzzi. It means number of gallons of water, yada, yada, yada. Or this is the height, yada, yada, yada. Okay? Be specific. Exactly what value is the meaning of the value that each expression calculates. Go. Work together.
Is formed after
It's not a preference. We want us to like this.
No, it's after.
So it would represent an additional number of gallons after 128. Makes sense?
Now, going after.
Got it?
After.
It means for any point after.
Next final is next final is next value. Next final is
Oh, was that one? Yeah.
Okay, where is Laura Alonso? Where's Laura Alonso? How'd it go? So what did you say x minus 128 is? It's a change in number of gallons. Can you be more specific though? Yeah, that's true. It's a change in number of gallons from where? Okay, so it's the additional number of gallons after 128 gallons are added. Is there another way to say this? Is there another kind of way to frame this? Thinking about just the jacuzzi.
From the bottom.
It's not from the bottom.
No.
What number of gallons is this? Yeah. Okay, is it, so just from some point in the second to some point in the first, like this? Is that right? Which one? So what I heard you say was it's just like start anywhere down here, go to anywhere up here, and you get that's the number of gallons from there to there. Is that what you meant? Okay. Yeah. After 16 inches? He said the number of gallons after 16 inches of height. Yeah.
Yes.
Right. Yes. So it's the number of gallons in the wider part. In the wider part. So above that, starting at the step. Starting at 16 inches, starting at 128 gallons, starting at the step, it's the additional number of gallons that you have. So those are all ways to say it. Okay? All right, how about 0.045 times x minus 128? Where is Kevin Kanitsky? All right, Kevin. What is point when you take 0.045 times that? What do you got?
It's the change.
Okay, okay, but we're talking about the jacuzzi, right? Talk to me about the jacuzzi.
So it's the change in x times the constant. So it's the change in y after the first steps.
And what does y represent in this situation? So talk the height. So it's the change in height from change in height. So let's say from the step. From 128 gallons. Change in height in inches from the step. What is this about? 0.045 times x minus 128. It's a huge thing we've been hammering. What is it? K delta x. K is a 0.045 times the change in x, right? So in this top part of the step, the relative size of changes in y to changes in x are 0.045. X minus 128 is the change in x in that top step. So we're going to get the change in y in the top step, or the change in height. So this is essentially saying delta y equals k delta x. That's what that is. So we get the change in height starting at the step, from the step. What's j of 128? What is j of 128? Yeah.
It's the height of water.
Height of water. Oh, what's happening? Height of water.
The number of gallons is 128.
Okay. When at 128 gallons. And what height is that?
The first step.
What's that?
First step.
The step. Yeah. So it's the height of the step. So this is the height of the water, or the depth of the step, right? Okay, and then if we take this expression and add it to this one, what do we get? Melinda Hickox. Where's Melinda? Melinda? So now we're going to add 0.045 x minus 28 plus j 128.
That's like the total height of the water from the bottom step.
She said the total height of the water from the bottom. What do you think? Yeah, so if you have the height from the step, the k delta x, plus the j of 128, which is the height of the bottom portion, the total height will be now the height of the water from the bottom. It does this weird thing, I know. And what is the output of j? What's our output quantity of the function j? The height of the water, that's the rule for j, right? That's the rule for j in the upper portion. So it better give us the output of this function, which is height of the water from the bottom. So that makes sense, right? Because that is the whole rule, it better be the same as the output of the function, the height of the water from the bottom. Okay, any questions? Okay, top hat. Let's do top hat. In the middle today.
Middle?
Middle of class.
Oh. Middle class.
What would it be? LX How many pieces? 3. So m times x minus a plus b. 4. -3 to 1. Agree?
Agreed.
And then our next piece is going to go from what to what?
3.
1 to 3. And we don't want to put 1 on this line because we're going to use L of 1 from this line to define this line, right? So we want to make sure that 1 is x equals 1 prompts this line to come up, not this one. So what's our constant rate? 1.68 times x minus the starting x value plus L of 1, the y value. That's it. Okay, then our next range is from 3 to 10. Constant rate is -0.52. X minus what? 3 plus L of 3. That's the whole function. You had to put in the second line. What was that, like D or E or something? Questions on building that piecewise function? Does it make sense? So at the first piece, we get to that last point, which is x value of 1. And we're just take 1 L of 1 to be that starting point of the next piece. 1 comma L1 is the point that we'll use on the next piece. Knowing its constant rate of change, we can just write using the point slope form. $15 seconds. Get your answer in. Okay, going. All right, what do we do? P of 2 is going to go to which line first? Second line. Yep, because 2 is between 1 and 3, so we're going to plug 2 in here. We're going to get 3 times 2 minus 1 plus P of 1. So that's 3. 3 plus P of 1. How does it evaluate P of 1? First line, right? 1 is from the first line. So we're going to do 1 plus 4 minus 7 is -2. 3 plus -2 is 1.
So,
How do we do? Pretty good. Sweet. Makes sense to most people. Good. Okay. So, piecewise functions. So let's see a really good example of piecewise functions. More complicated now in the real world. But we got a little bit more to do. Hold on. Before we get there. Okay? Is it constant rate of change?
that one is.
Estimate the value of the constant rate. What is the value of the constant rate? What could you say about this? What's the constant rate of change? I heard 2.
Uh, 4 or 3.
No.
What is it we're looking for? We're looking for the relative size of the change in y with respect to change in x. And relative size is quotient. So we want delta y divided by delta x. Okay? So that stays the same for all delta x, that relative size. And this is 2 here. Okay?
I got still better than
All right, so for every 1 that you go delta x, you're going to get a change in 2 of delta y. For any delta x, you're going to get 2 times Here's our big important result here, right? For any delta x that you pick, if the relative size of delta y to delta x is 2, then to get delta y, you're going to multiply delta x by 2. Should make sense. Delta y is always twice as much as delta x. And because it's always true, we get constant rate of change. Okay, so how about this? So here is another way. This graph on the left is now a new way to graph that rate. So we said that's constant rate of change. So at any x value, so over here, at x equals 1, what is the rate of change at x equals 1? What's the rate of change? 2. At 0, what's the rate of change? 2.
Still 2.
At negative 1.5, what's the rate of change?
Still 2.
2. So this graph on the right, its y values are the measure of some quantity. But we could create a graph where the y values are no longer the measure of the quantity, but the rate of change. So it's the same x values. And what was the first question I asked you? I said, at x equals 1, what is the rate of change over here? 2. So this graph is showing that by the point 1, 2, this is no longer the y, the measure of the quantity y, but the constant rate of, or the rate of change at x equals 1. And then I said at 0, what's the value of the rate of change? So over here at 0, x equals 0, it's showing the point 0, 2, which is showing, instead of showing the y value, the measure of the quantity, it's showing the rate of change. And then I said at negative 1.5, what's the measure of the rate of change over here? 2. So come over to negative 1.5, and there's a point on this graph. Negative 1.5, and the output now is the rate of change of y with respect to x, where y is shown on the right graph. The output, the y-axis over there now is the rate of change. So if it's a constant rate of change of 2, then the rate of change graph will be this horizontal line at 2. Everywhere, any x that you pick, you're going to get that rate of change of 2. Does it make sense? Okay, all semester long, we're going to be looking at side-by-side graphs like this. X is the same on both graphs. On the right, there's going to be some y value, some measure of a quantity, height, temperature, volume, distance, something. The left graph, its y-axis, for the same x, its y-axis will be showing the rate of change of that quantity that we're showing on the right graph. So this configuration, this is our first look at something we're going to see all semester. A rate of change graph, the y values give the rate of change of this quantity that we're graphing on the y-axis on the right. Does it make sense? Okay, cool. So, what's that showing? For every delta x, it's showing the same constant rate of change over every interval of length x. And that constant rate of change is 2. Over here. Same constant rate of change over every interval of length x, which is 2. So the y value on the right is the measure of some quantity. So that rate of change will be seen by the slope of the graph. On the left graph, the y value is the rate of change. So the rate of change is seen by the y value. So here's one. Here's a rate of change graph. Can you draw the corresponding quantity graph on the right? See if you can do it. So this is a rate of change graph. It's a great one for your whiteboards if you got your whiteboard. Okay? That's the rate of change graph. Draw the function f. Draw the function f for that rate of change graph.
Okay. Let's let this game begin.
So R sub f, that's the name of the function. It means the rate of change of f. You're drawing the function f over here, whose y values are the outputs of f. You're drawing a graph. You're sketching a graph. You're just sketching a graph. Trying to sketch a graph whose rate of change function would look like this.
So at x equals 2, what's the rate of change? What's the value of x equals 2? Should the rate of change be? So you showed me that this has a rate of change of 1. This is rate of change of negative. Which is it at x equals 2? At x equals 2, is the rate of change 1 or is it negative? Check it point by point. So you have a hypothesis. Right. Alright, so it's that way. Okay, so what's the rate of change right there? I think it's start with. People are getting it.
Okay, so lots of you have something, but here's my question. Is there only one possibility?
No. There are many more.
Lots of you drew this. This is correct. This works. The rate of change function for this one is this one. Rate of change of 1, if x is greater than 0. What's the rate of change here? Negative 1, if x is less than 0. But is this the only graph that has that rate of change profile?
I don't know what the x and y values
Okay, this is 1, right? So what about this?
Yes.
Does it work? Yeah. If x is greater than 0, rate of change of 1. If x is less than 0, rate of change of negative 1. There's another one.
Yes. That works.
Okay, any questions? Does it make sense? Y, on the right, the y values are the value of a quantity. On the left, the y values are the rate of change of this one on the right. Okay, so let's talk about taxes.
Oh, nuts.
Oh, it's so easy for you guys. You just have maybe just one thing of income, right? They grown. Okay, so what's the basis of the values? Where do they come up with these numbers? There has to be a rhyme or reason to this. What's that? So, does everybody pay the same percent of their income in the United States? No. What happens? If you make more, you pay, well, but if everyone's paid the same percent, that would still be true. If everyone paid the same percent of their income, if you made more, you would pay more. But it's even different than that. If you make more, you pay a higher percent. You pay a higher percent. Okay, so let's see how this works. So here's the tax rate function. Okay, what's the input and what's the output? So let's look at this. What's the input of this function? What is x? X is?
how much the person makes.
Okay, so taxable income. So it's a little different than your total income because certain things that can be deducted, right? So you can reduce your total income to get the amount that's taxed. Okay, so X is your taxable income in dollars. And so then what is the output of this? Tax rate of X is what? That means output, right? This whole thing is the name of the function. So this is an output. In the tax rate function, what is the output? How much money you pay? Take a look at what's going on here. It's a percentage you pay. Okay, so if your taxable income is $50,000, that would take you here to line 3. And what does this say? So do you pay 25% on all $50,000? Is that what that says? Actually, no. What this is saying is you're going to pay 25% on the next dollar that you make. If you make $50,000, then on the next dollar that you make, you'll pay $25,000. 25%. 25%. How much, what percent did you have to pay on the $10,000th dollar that you made?
15.
15%, 0.15. Okay? So even if you make $50,000, it's only these dollars from $34,000 to $82,400 that you pay 25% on. Previous money that you made before the $34,000 was taxed at this lower percentage. Okay? This is what's called a progressive tax system. So it's not that if you make $500,000, you pay 35% on all $500,000. You're going to pay 10% on.
What happened?
Okay? So it's if you make $500,000, you're in the last bracket here. If you make $500,000. Okay? It doesn't mean you pay 35% on all $500,000. It means that for these dollars that you made at the beginning of the year, you pay this percent. Then once your income hit 8,370, you started paying 15%, etc. Okay? So, is this, say this 0.333, is it a rate of change? Is that a rate of change? And if it's a rate of change, then it's the size of what relative to what? We know that rate of change is delta y over delta x. So 0.33 is the amount of what relative to what? Tell the person next to you. What quantity relative to what quantity? 0.33. Where's Rochelle? Rochelle Scoot. You're up. What did you say? What do you think? The amount of what relative to what? 0.33, so a third. So that's basically saying a third. A third is the amount of what relative to what? Okay? Yeah, it's the amount of tax you pay relative to what? Yep, relative to amount earned in this bracket. It's going to be about 1/3. So whatever amount you've earned in this bracket, the tax you pay will be 1/3 of that, 0.33 of that. Relative size, delta y over delta x. Okay, so this is a piecewise function that's giving us rate of change, piecewise rate of change function. Okay, so now what about the actual tax function, the tax function? Don't be scared. This is exactly what we did earlier in class. This is not, there's nothing hard about this, okay? You can do this. So what are the input and output quantities of this function? So it's just longer. That's all it is. It's just longer than what we did earlier. That was easy. What are the input and output quantities? What's the input? X is taxable income still. What's the output? This is total amount of tax in dollars that you're going to pay for that income. And we saw that it's not just if you're in that second to last bracket. It's not 0.33 of all the money you've made. That's where this recursive idea comes in. It's going to be the tax you made in the first bracket, plus the tax you made in the second, plus the tax in the third, up to whatever, okay? What's the form of each line? So the structure is a piecewise function. Each line has what form? Do you see it? Let me just circle one so you can highlight it here. What's the form of that? Should recognize it. Point slope, m times x minus a plus b. M times x minus a plus b. Okay, so now, what are the meaning? So line 3. I guess it's line 2. The one I circled. Should say 2. Oh no, it is line 3. It's line 3. Okay? So the one I circled, just like we did for the Jacuzzi function, I want you to go through each one of these expressions and say what's the meaning of the value that you would get from each one of those expressions. Super important that you can identify what each of those is. Go. Okay, where's Xavier Ramirez? Xavier Ramirez. Not here. Okay, how about Melvin? How do we do? So Melvin, what about that first x minus 34,000? Okay, so it's the number of dollars earned above 34,000, or the change in amount earned since you made 34,000.
Can we say additional?
Additional number of dollars after making 34,000. Yeah. So it's how much money you make in this bracket. It's how much money you make in this bracket, the 34,000 to 82,400 bracket. There's 5, 6 ways you could say it. 0.25 is? It's the rate of change. It's the relative size of how much tax you pay to how much you earn in that bracket. So it's the tax rate for this bracket, the relative size of the change in tax to the change in income. What about when you multiply those two together? What do you get? Change in? The amount of tax owed on dollars earned at this rate, or the change in amount of tax since you paid all the tax up to 34,000. So this is the amount of tax owed on this rate, okay? Tax of 34,000 is all the tax you paid before, up to that bracket. So if you add them together, you get total taxes you pay on your taxable income, on X dollars earned. So it's everything from before, tax 34,000, plus the tax at this new rate of 0.25. So you've got your GC assignment. You're going to email back by midnight tonight, and then I'll post Tuesday's homework. It'll be posted by 5 o'clock today. Okay? Have a good weekend.